Hi guys, good day. I'm Archivard B. Claro, and today we're going to discuss about conic sections. At the end of this video, you're able to define conic sections, circle, ellipse, parabola, and hyperbola under equations. Manipulate the standard form of the equations of conic sections, identifying key features such as foci, vertices, axis, and center. And lastly, graph conic sections accurately. So without further ado, let's start and do this topic. Now, conic section. What is conic? Conic, this is a derived from the word cone, which is cone is a three-dimensional solid geometric shape having a circular base and a pointed edge at the top. It's like this. Circular base and a pointed edge at the top. This one. This is like cone. Now, what is conic sections? Conic sections, these are the curves that result from the intersection of a right circular cone and a plane. Imagine that we have a plane, and if the plane intersects the cone, what we call the right circular cone, it can create a curve called the conic sections. Now, what is a right circular cone? Right circular cone consists of two cones joined together, joined at a fixed point called the vertex. The line that rotates the vertex is called the generator. The vertical line that remains fixed is called the axis. And a right circular cone has a base, circular base, and its axis is always perpendicular line from the center of the base to the vertex. This is a right circular cone. Imagine that if we have a plane intersect the right circular cone, it can create a curve called the conic sections. Now, let's start first with this first figure. As you can see, this is our plane and this is our right circular cone. This is our right circular cone and this is our plane. If a plane cut the right circular cone perpendicular to our axis, this is our axis, perpendicular, or parallel to our base, if a plane cut the circular cone parallel to our base, it can create a curve called a circle. And if a plane, in figure 2, this is our plane and this is our right circular cone. And if a plane cut the right circular cone not parallel to our base, we can generate a curve called ellipse. And if a plane cut the right circular cone, this is our plane, cut the circular cone parallel to the generator, this is our generator, a plane cut the right circular cone parallel to the generator, we can generate a curve called a parabola. And if a plane cut the right circular cone vertically, this is our plane, imagine this is our plane, this one, cut the right circular cone vertically, we can create two curves, and these are called the hyperbola. Now, these are the types of conic sections: circle, ellipse, parabola, and hyperbola. Now, let's focus first on the first type of conic section, which is the circle. Now, what is circle? Based on the definition, circle is the set of all points in a plane equidistant from a fixed point. As you see the figure, this is our fixed point, which is the H and K. And the set of all points, these are the set of all points. Imagine that this is our center, and the distance from a point is called the radius. This is our center, and this is our point. The distance, the constant equal distance, is what we call the radius. Now, the circle with a center at the point h and k and radius has an equation of x minus h squared plus y minus k squared is equal to r squared, where r is greater than 0. The general form of an equation of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0. Now, let's have an example. Find the equation of the circle by this given condition, which is center is at -1, 2, and through the point 3 and 1, -1. Now, how to find the equation, the standard equation of a circle using this given condition? First, we must identify the center. Center, h and k, which is -1 and 2. Our point, x and y, is equal to 3 and -1. Now, remember that the standard equation of a circle is x minus h squared plus y minus k squared is equal to r squared. Now, since we have the center and we have the point, all we need to do is to substitute. Now, rx is 3 minus rh is -1 squared plus ry is -1 minus rk is 2 squared is equal to r squared. Now, 3 minus -1 is equal to 4. 4 squared is equal to 16 plus -1 minus 2 is equal to -3. -3 squared is equal to 9 is equal to r squared. 16 plus 9 is equal to 25 is equal to r squared. Square root, we have 5 is equal to r. This is now our radius, 5. Since our standard equation is x minus h squared plus y minus k squared is equal to r squared. Now, a standard equation is x positive, since it is negative and negative times negative is equal to positive, so we have positive 1 squared plus y minus rk is 2 squared is equal to, or r squared is equal to 25. This is now the equation of the circle by this given condition. Now, let's graph this circle. We have, let's make a Cartesian plane. Now, since we have a Cartesian plane, now our center is -1 and 2. This is the -1, and rx is -1. This one, -1, and our k is 2. Therefore, dito. 1, 2. This is our center. Now, our R radius is 5. So 1, 2, 3, 4, 5. This is now our radius. Let's make a circle. Bypass the circle. Sorry. This is now the graph of our circle, having an equation of x plus 1 squared plus y minus 2 squared is equal to 25. Have a second example. Find the center and radius of the circle, having the equation x squared plus y squared plus 6x minus 4y minus 23 is equal to 0. How to find the center and radius? Now, as you can see, this equation is in a general form of an equation of a circle. Now, the standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. We need to manipulate this equation, this general form, into standard form. Now, how to do that? First is we need to group like terms, x squared plus 6x plus y squared minus 4y. Since it is negative 23, you need to add both sides by 23, so plus 23 plus 23 and cancel is equal to 23. Next, as you can see, we can complete the squares by we need to completing squares. We have x squared plus 6x, 6 divided by 2. We have 3 times 3, 3 squared is equal to positive 9 plus y squared minus 4y, 4 divided by 2 is equal to 2, 2 squared is equal to positive 4 is equal to 23. Since we add positive 9 and positive 4 in this side, we also need to add positive 9 and positive 4 in the other side. Now, simplify. 23 plus 9 plus 4 is equal to 36. Now, this equation, we can transpose it into x plus 3 squared plus y minus 2 squared. As you can see, this is now the standard form of the circle. Now, remember that the center of circle is h and k, which is this is our h and k. So center is, since it is positive and the standard form is negative h, so meaning it is negative 3, positive 2. So our center is negative 3 and 2. Now, is our radius. How to find the radius? Since here our radius is 36 is equal to r squared, that is r squared. So r squared, r is equal to 6. Now, this is our center, negative 3 and 2. Our radius is 6. Now, let's graph this circle. One, two, three, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, since we have Cartesian plane. Now our center, negative 3. 1, 2, 3, negative 3, and positive 2. 1 and 2. Ry 2, 1. Now our radius is 6. So 1, 2, 3, 4, 5, 6. This is our radius. Now the circle looks like this. Sorry. This is the center and this is the radius. Proceed to our second conic section. That is what we call ellipse. The definition of ellipse is that the set of points in a plane, the sum of whose distances from two fixed points is a constant. Each fixed point is called a focus. Now to have a better understanding, let's look at this figure. As you can see, we have focus, we have two foci. Now based on the definition of an ellipse, the sum of the distances from any point, since these are the set of all points of the curve. Now, and imagine this is our point. Now, the set or the sum of the distances from any point on the curve to two fixed point is a constant. That is now the definition of an ellipse. Now let's proceed to the parts of an ellipse. Let's have first the major axis. Major axis is the longest diameter of the ellipse. Now as you can see to this figure, we have the x and y axis, and x-axis has the longest diameter, meaning this is our major or our principal axis, and major axis denoted as A. That's why we have vertex negative A0 and A0. Oh, take note that major axis has length of 2A. Now let's proceed to minor axis. Minor axis is the shortest diameter of the ellipse. Since the y-axis has the shortest diameter, now this is now our minor axis. Minor axis denoted as B. That's why we have vertex 0B and 0 negative B. And the length of minor axis is 2B. Now, ellipse has focus. It has two foci, and foci denoted as C. That's why we have negative C0 and C0. To find or to solve for C, we will use this formula. We have C squared is equal to A squared minus B squared. And always remember that the foci is equidistant from the origin. This is our origin. Now the two fixed point is equidistant from the origin. Now next we have a center. Center is the midpoint of the line joining the two foci. This is our two foci. Midpoint, we have the center, denoted as H and K. HK. Now let's proceed to the equation of an ellipse. Now the equation of an ellipse is x squared over a squared plus y squared over b squared is equal to 1, or x minus h squared over a squared plus y minus k squared over b squared is equal to 1. H and k there is our center. That is the equation of an ellipse. Take note that if the center of an ellipse is at origin hk and the distance between vertices is 2a, then equation is x squared over a squared plus y squared over b squared is equal to 1. If the principal axis or the major axis is horizontal, meaning our principal axis is at the x-axis. We will use this formula if our major axis is horizontal. Now, if the principal axis is vertical, or the major axis is vertical, or the longest diameter is vertical, we will use this formula. We have x squared over b squared plus y squared over a squared is equal to 1. Again, if the principal axis is vertical or it lies on the y-axis, we will use this formula. Let's have an example. A. For the ellipse having the equation x squared over 25 plus y squared over 16 is equal to 1. Find the vertices, endpoints of the minor axis, and foci. To solve this problem, first let's copy the equation x squared over 25 plus y squared over 16 is equal to 1. As you notice, it has the longest diameter, meaning our major axis lies on the x-axis. So x squared over a squared plus y squared over b squared is equal to 1. This is now the formula that we are going to use. Now, first find the center. Since it has no HK, meaning the center is at the origin. So 0, 0. Next, we will find the vertex of the major axis. Since our major axis is A, and our A here is 25, A squared here is 25, therefore A squared is equal to 25. Square root of A squared square root of 25 is equal to A is equal to 5. Therefore, our vertex of major axis is negative 5, 0 and 5, 0. Next, our vertex of minor axis. Now, our minor axis is denoted as b, right? So b squared is equal to the value of b squared is 16. Therefore, square root to find the b. b is equal to square root of 16. We have 4. Therefore, our vertices are negative 4. No. Since minor axis is at the y-axis, meaning our vertices is 0, negative 4, and 0, 4. This is our vertices of minor axis and vertices of major axis. Now let's find the foci. Again, foci denoted as c, right? Denoted as c. Now to find the distance or to find c, we will use c squared is equal to a squared minus b squared. Next, you just substitute the value of a and b. So a we have 5, a5 squared minus our b is 4 squared. So c squared is equal to 5. 5 times 5 is equal to 25 minus 4 times 4 is 16. Now c squared is equal to 25 minus 16. We have 9. Now square root of c squared is c square root of 9 is 3. Therefore, our foci is 3, 0 and negative 3, 0. Since we all identify the foci, the vertices of minor axis and the major axis, and the center, we can now graph the ellipse. So to graph this ellipse, first we make a Cartesian plane. Yeah. Sorry, my drawing skills is not. Next, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Next, this is our center, 0, 0. And our major axis is at negative 5, 0 and 5, 0. Since 1, 2, 3, 4, 5. This is our vertex 1, 5, 0. 1, 2, 3, 4, 5. This is our vertex 2 or negative 5, 0. Next, our minor axis. Our minor axis, we have 0, negative 4, 1, 2, 3, 4. Dito. 0, negative 4. Next is 0, 4. 1, 2, 3, 4. Dito. 0 and 4. And next is our foci. Foci located at 3, 0, 1, 2, 3. Is our foci. And negative 3, 0. 3, 0, foci. Negative 1, 2, 3. This is now our negative 3, 0. Next, all the dots. Now, just connect all the dots. Oh, sorry guys, my drawing skills is not drawing. The ellipse looks like this. Our ellipse looks like this. Okay. Now let's proceed to our second example. We have next example. Find the center, vertices, and foci in each of the following ellipses and graph. Now we have here an equation: 25x squared plus 9y squared is equal to 125. Let's make this equation into a standard form or standard equation of an ellipse. Standard equation of an ellipse, we have x squared over a squared plus y squared over b squared is equal to 1. Now, to make this equation into this equation, let's copy solution. 25x squared plus 9y squared is equal to 225. Now, let's divide both sides by 225. Now, 225 divided by 225 is equal to 1. And 25 over 20 by 25x squared divided by 225, we have x squared over 25 divided by 225, we have 9, 1 over 9, so 9 plus 9y squared over 225, we have y squared over 9 over 225, we have 25. Now, as you can see, 25 is greater than the 9. Therefore, our major axis lies in y-axis. So therefore, our formula that we are going to use is x squared over b squared plus y squared over a squared is equal to 1. Therefore, we can now find the center, vertices, and foci, since our center is at the origin. Next, we can now find the vertex of major axis. Since our major axis is at the y-axis, so, and major axis denoted as a, therefore, to find a squared is equal to 25. To find a, square root. So a is equal to 5. Since it lies on the y-axis, therefore our vertex are 0, negative 5, and 0, 5. These are vertex of major axis. And vertex of our minor axis, since minor axis denoted as b, therefore b squared is equal to 9 for square root. B is equal to square root of 9, we have 3. Since our minor axis is at x-axis, therefore 3, 0, and negative 3, 0. Now let's find the foci. To find the foci, we will use the formula c squared is equal to a squared plus b squared. Since foci denoted as c, right? So therefore, c squared, just substitute the value of a and b. So 5 squared plus 3 squared. C squared is equal to 25 times 5 is 25 Plus 3 times 3 is 9. I know, the formula that we're going to use is not plus, it's minus. Sorry, it's minus 9. So c squared, 25 minus 9, we have 16. So square root of 16 to find c. So c is equal to 4. Therefore, our foci, since foci and the major axis is at the same axis, therefore it lies on the y-axis. Therefore, 0, 4 and 0, negative 4. That is now our foci. Now let's now graph, since we have the foci, the vertices, and the center. We can now graph the ellipse. So let's make a Cartesian plane. One, two, three, four, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now again, our center is at the origin. Our major axis lies on the y-axis. Therefore, 0, negative 5. 1, 2, 3, 4, 5. Dito. 0, negative 5. And 0, positive 5. 1, 2, 3, 4, 5. Dito. 0 and 5. Next is our minor axis. 3, so 3, 0. And negative 3, 0. 1, 2, 3. Dito. Negative 3, 0. Next, we have the foci. Since foci, 0 and 4, 1, 2, 3, 4. So this is now our foci. And 0, negative 4, 1, 2, 3, 4. Negative 4. Now let's connect the dots. I'm not good at drawing this. So our ellipse looks like this. Our ellipse looks like this. Next, we will proceed to the next conic section. Now, let's proceed to the third conic section. That is what we call the parabola. The parabola is the set of points in a plane that are equidistant from a fixed point and a fixed line. Now, let's look at this figure. Based on the definition of parabola, the fixed point and the fixed line, fixed point is our focus and fixed line is our directrix. And the set of points in the plane is always equidistant to our fixed point. Again, the set of points in a plane are equidistant to our fixed point or to our focus and also to our fixed line, meaning that is equidistant. Now, let's go to the parts of parabola. First, we have the vertex. Vertex is the origin or the center, denoted as HK. Next, we have focus. Focus always, we can always see the focus where the curve opens. Now, this is now the focus, and the distance from vertex to focus denoted as P. That is the distance from vertex to focus. And the chord through a focus parallel to the directrix, since this is the directrix, since the chord or ito is what we call the latus rectum. And the latus rectum is equal to 4p, since the point here from point here to our fixed point is equal to 2p, and is same to the other side since the set of points are equidistant to our focus. So we have 2p plus 2p, we have 4p. Now, next we have the directrix. The directrix is perpendicular to the axis of symmetry. This is our axis of symmetry. Always remember that the directrix is perpendicular to our axis of symmetry. That is our directrix. And take note that the distance from vertex to directrix is equivalent to the distance from vertex to focus. They had same distance, denoted as p, since they are equivalent. They have the same value, the same distance. The equations of parabola. First, we have an equation of the parabola with focus 0p and directrix is y. Negative p is x squared is equal to 4py, or x minus h squared is equal to 4py minus k. Remember that hk is the center. And take note that if p is greater than 0, the curve of the parabola opens upward. And if p is less than 0, the parabola opens downwards. Now, let's proceed to the second equation. An equation of the parabola with focus p0 and directrix x negative p. We can use y squared is equal to 4px, or y minus k squared is equal to 4px minus h. Take note that if p is greater than 0, the curve of the parabola opens to the right. And if p is less than 0, the curve of parabola opens to the left. That are the two equations that we're going to use. That are the equations of parabola. Now let's have an example of the parabola. First, we have sketch the parabola having the equation y squared is equal to 12x. Solution. Y squared is equal to 12x. As you can observe, it is y squared. Therefore, its axis is the x-axis. Next, let's find the focus. In able to graph this parabola, we need to find the focus, the vertex, the latus rectum, and the directrix. First, let's find the vertex first. Let's find the vertex. Since y squared is equal to 12x, and our vertex denoted by h and k, therefore our vertex is 0, 0, since its vertex is at the origin. Center is at the origin. Next, let's find the focus. To find the focus, let's find first the p. To find p, we all know that the formula of a parabola is y squared is equal to 4px. Therefore, to find p, 4p is equal to 4p here is 12. Therefore, 12 divided by 4, p is equal to 3. Therefore, the focus is 3, 0, because the distance p is the distance from vertex to the focus. First 3, 0. Next, we will find the directrix. Take note that the directrix is distance. It has the same distance of the focus and the directrix. They has the same distance. Therefore, x is equal to negative 3. Next, we'll find the latus rectum or the endpoints of latus rectum. To find the latus rectum, we will use the formula latus rectum is equal to 4p, absolute 4p over 2. So for 4 and our p is 3, 2, 12 over 2 is equal to 6. Therefore, our latus rectum or the endpoints of latus rectum is 3, 6, and 3, negative 6. That is our latus rectum. Since we already find the latus rectum, directrix, focus, and vertex, we can now graph the parabola. To graph this parabola, let's have a Cartesian plane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. First, our vertex is at the origin. Next is our focus. Since our focus is 3, 0, and its axis is the x-axis, since it is the x-axis and it's the y-axis. So, since p, that if e is greater than 0, therefore the focus opens to the right. So therefore our focus is 3, 0. This is our focus. Next is the directrix. The distance from the vertex to the directrix is equidistance from focus and the directrix. So since we have 3 here, we also move 3 here. So x is equal to negative 3. So 1, 2, 3, negative 3. So this is now our directrix. X is equal to negative 3. Next, we have the latus rectum. Since latus rectum is how wide the parabola is, the latus rectum determine how wide, or yeah. So therefore, the latus rectum is 3, 6. So where is x or 3 and 6? 1, 2, 3, 4, 5. Let's add another one. Let's add here 3, 6. Therefore, 3, 6 we have dito, and 3, negative 6 is dito. This is now the latus rectum. And now let's connect the these points. We have a parabola looks like this. This is the directrix. This is the curve. This is the graph of this equation. Let's have a second example. We have find the equation of the parabola having vertex 0, 0 and directrix is y is equal to negative 1. So since vertex is already given 0, 0 and the directrix is y is equal to negative 1, we can now find p and focus. Right, we can now find p and focus because the directrix and the focus lie at equal distance. So therefore, p is 1. Therefore, our focus, since focus and the directrix lie at equal distance from the vertex, therefore our focus now is 1, 0, 1. Next, since we have focus and vertex, we can now find the equation of the parabola. As you can observe, directrix is y is equal to negative 1. Therefore, we can use the formula x squared is equal to 4py. Since the vertex is not at the origin and the directrix is y is equal to negative 1, we can now find the equation. X squared is equal to 4, our p is 1, and y, so therefore x squared is equal to 4y. This is now the equation of this parabola. Next, we will find the latus rectum. To find the latus rectum, we have absolute 4p over 2 is equal to 4, 1 over 2, 4 over 2, we have 2. Therefore, our latus rectum is 2, 1, and negative 2, 1. Now, since we have the latus rectum, the focus, and the directrix, and the vertex, we can graph now the parabola. Again, since the directrix is y is equal to negative 1 and p is equal to 1, or p is greater than 0, therefore our parabola opens upward. So, now the directrix is negative 1. So here, this is our directrix. And our focus is at 0, 1. Dito. This is our focus. And our vertex is dito. 0, 0. And our latus rectum is 2, 1 and negative 2, 1. So 2, it's 2 and 1. And negative 2, 1. Ito. So this is the latus rectum. Now let's connect the points. The parabola looks like this. This is the directrix, y is equal to negative 1. This is the focus, we have 0, 1. And the vertex is 0, 0. And this is the endpoints of latus rectum. Now this is the graph of x squared is equal to 4y. That's all for the parabola. Now let's proceed to the fourth conic section. That is what we call the hyperbola. A hyperbola is the set of all points in a plane, the difference of whose distances from the two fixed points is constant. Now let's look at this figure. We have two foci, or two fixed points. And every point in a plane has distances to the foci that gives a constant difference. That is the definition of hyperbola. Now let's go to the parts of the hyperbola. First, we have the transverse axis. Transverse axis, it is passes through the foci, vertices, and center. Now we have the center. Center denoted by HK. And we have two vertices. And the distance from center to vertex denoted as A. That's why our vertices we have negative A0 and A0. And we have two foci. And the distance from the center to foci denoted as C. That's why we have negative C0 and positive C0, where C squared is equal to A squared plus B squared. Next, we have the conjugate axis. The conjugate axis, it is a perpendicular to our transverse axis. In the conjugate axis, we can see the endpoint of our conjugate axis, which is B, denoted as B. Next, we have the diagonals, the diagonal line, which are the asymptotes. Asymptotes are lines that the branches approaches, getting closer and closer, but never touching. As you can see, this is the branches of our parabola. And this is the asymptote. It's getting closer and closer, but never touching. That is the asymptote. Now, this figure, or this hyperbola, we can this hyperbola called a horizontal hyperbola. This is horizontal hyperbola, where it has an equation of x squared over a squared minus y squared over b squared is equal to 1, or x minus h squared over a squared minus y minus k squared b over b squared. Remember that hk is our center. Now, it has foci, positive and negative c0, where c squared is equal to a squared plus b squared. Vertices, positive and negative a 0. This one, these are the vertices, these are the foci. And the asymptote, the formula for asymptote, we have positive or negative b over a x. That is the formula to find the asymptote. Now remember that if x term is first, the hyperbola opens around the x-axis, or we have a horizontal hyperbola. Next, we have what we call the vertical hyperbola. Vertical hyperbola has an equation of y squared over a squared minus x squared over b squared is equal to 1, or y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Remember again that our h and k is the center, and it has foci 0, positive, and negative c, where c squared is equal to a squared plus b squared. Next, we have the vertices. Vertices is 0 plus or negative a, here vertices, and the formula for the asymptotes are positive and negative a over bx, or positive a over bx, that is the asymptote. Take note that y term is first, our hyperbola opens around y-axis, meaning we have vertical hyperbola. The curve opens downwards and upwards. That is the equations of hyperbolas. Let's have an example of hyperbola. We have find the standard equation, vertices, foci, asymptote, and of the hyperbola having the equation x squared minus 4y squared is equal to 16. So solution, we have the equation for x squared minus 4y squared is equal to 16. Remember that the standard equation of the hyperbola is x squared over a squared minus y squared is equal to b squared is equal to 1, right? Having a center of 0, 0, right? So let's make this equation into the standard equation. So let's divide both sides by 16. Therefore, 1 x squared over 16 minus 4y squared. So y squared over 4 over 16, we have 1/4. So now this is now the standard equation of this hyperbola. Now, next, we can now identify the center. Since center is at the origin, we have 0, 0. Next, find the vertices. To find the vertices, remember our vertices denoted as a. So to find a, we have a squared, since this is our a squared and this is our b squared, so a squared is equal to 16. To find a, square root, a is equal to 4. Remember that if x term is first, so opens around x-axis, right? Opens around x-axis, so we have horizontal parabola. So therefore, our vertices, we have 4, 0, and negative 4, 0. So the vertices. Next, we will find the foci. Remember that foci, or the distance from the center to foci, denoted as c, right? So to find c, we will use the formula c squared is equal to a squared plus b squared. We have a, right? We have a, but we don't have b. So we will find first b. So b squared, since b squared we have 4, right? So the value of b is 2. So c squared is equal to a squared, 4 squared plus 2 squared. we have c squared is equal to 4 times 2, 4 times 4 is 16, plus 2 times 2, we have 4. So c squared is equal to 16 plus 4, 20. Square root to find c. C is equal to square root of 20, we have 2 square root of 5. This is now the value of c. Therefore, our foci is at 2 square root of 5, 0, and negative 2 square root of 5, 0. Next, we will find the asymptote. To find the asymptote, we will use the formula y is equal to positive negative b over a x. Just substitute the value. So positive negative, our b is 2 and our a is 4. Therefore, we have 2 over 4, we have our asymptote is positive negative 1/2 x. This is our asymptote. Now we can graph our hyperbola. First we will draw a Cartesian plane. Since our parabola is a horizontal parabola, because x term is at first, so the curves opens around x-axis. So since center is 0, 0, and our vertex is at 4, 0, 1, 2, 3, 4, 1, 2, 3, 4. So this is the vertex, and the vertex we have 4, 0, and negative 4, 0. And our foci is at 2 square root of 5. So 2 square root of 5 is 4.47. 4.47. So ito around here. So 4 point ito yun. 2 square root of 5, 0, and negative 2 square root of 5, 0. Ito around here. Next, since we already have the vertices and it opens around x-axis, so therefore our hyperbola looks like this. Now let's find the asymptote. To find the asymptote, we have positive negative 1/2. So therefore 1, 2, 3, 1, 2, 3. So 1/2, 0.5, dito lang. And PS then 0.5. Then dadaan. Ito din, 0.5. Okay, 0.5. So therefore, our asymptote around, ayan. This is our asymptote. Don't worry, I will, the graph looks like this. Let's have a second example for hyperbola. We have the foci at 0, 5 and 0, negative 5, and a vertex at 0, 4. Find the equation of hyperbola. To find the equation of this hyperbola using this given condition, first we have the foci, right? 0, 5 and 0, negative 5. And a vertex, we have 0, 4, since also have 0, negative 4. Now, as you notice, the foci and the vertex lies on the y-axis, right? Therefore, the equation should look like this. Y squared over a squared minus x squared over b squared is equal to 1. the equation should look like this, and therefore we have a vertical hyperbola. Now to find a squared and b squared, since our center here is at the origin, so we have 0, 0, and to find a, remember that a here is the distance of the um, the center and to the vertex, right? So we have a is equal to 4. So you'll find the a squared, so a squared is equal to 4 squared, or 16. 4 times 4, 16. So a squared is equal to 16. And remember that foci is denoted as c, right? So c squared is equal to 5, since 5 squared. Therefore, c squared is equal to 25. Now, we have to find b, right? So to find b squared, so we need to use the formula c squared is equal to a squared plus b squared. We need to manipulate this and able to find the b squared. So c squared minus a squared is equal to b squared, right? So therefore, b squared is equal to c squared minus b squared. So b squared is equal to c squared is equal to 25 minus a squared is 16. So b squared now is equal to 25 minus 16 is equal to 9. We have b squared and we have a squared. Therefore, the equation is y squared is equal to 16 minus x squared over 9 is equal to 1. This is now the equation of this hyperbola. Now let's graph this equation or this hyperbola. We have a Cartesian plane. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now, sorry, 5, 5. Now our foci here is 0, 5, and 0, negative 5. So 1, 2, 3, 4, 5. So here, this is now our foci, 0, 5. 1, 2, 3, 4, 5. This is 0, negative 5. And our vertex is 0, 4 and 0, negative 4. So here, 0, negative 4, and 0, 4. Since it is a vertical hyperbola, and that opens upward and downward, so therefore it looks like the hyperbola looks like this, right? Don't worry, I will attach the graph of it on the screen. So this is the hyperbola, but we need to find the asymptote. To find the asymptote, we will use the formula y is equal to positive negative a over b x. Just substitute. A is equal to 4, right? And our b is equal to 3. Square root of 9 is 3. So therefore, our asymptote is 4 over 3. So around 1.33. So since it's our origin, center of origin, center, so around here. So the asymptote looks like this. Same way the other side. So the graph looks like this.